Following on from the previous video, we've established that our function is always climbing. So hang on. So we got to a stage where we established that our function is always climbing. And the reason why we know it's always climbing is because if you look at the first derivative, if you look at the first derivative, the you have to realize that the first derivative is always positive, always greater than zero. Because if you look at this thing here, if you look at this graph here, it will look like this. You can see that this bit here is always in a positive realm. Look, zeros here is always above zero. Okay, and then, well, if you look at this bit now, this bit here is always above zero. And then when you add 1, it's going to remain above 0. And when you square it, it will remain positive. So basically, this whole thing here will always be positive. So the reason why we know it's always climbing, the actual function itself, remember the function itself here, that's different from f prime. The function itself will always be climbing. And the reason why we know that is because f prime is always above 0. So that would imply that this thing is always climbing. Okay, so now we need to consider f double prime now. So we know our graph to look something like this. We're going to guess it's climbing all the time, like this. Okay, so now we need to look at the concavity here. So differentiate this. So starting with f prime here, differentiate it. So blah 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 blah, differentiate it, blah 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 blah, and then it gives you this thing here. Okay, so this here is our f double prime of x here. Okay, so this here is the second derivative. Okay, and then you could ask yourself, when will this be 0? That would be our point of inflection. So set this thing here to be 0. Okay, so the next question is, when will f double prime be 0? Okay, so set this to 0 here. So that's you trying to find this out here. When will this be 0? Okay, so let's look at this. Let's just imagine it as this: one bubble here, one bubble here. So multiply both sides by the bottom bubble. That will then, well, you trying to solve this here is the same as you trying to solve this here. Okay, so when would this be 0? You see, if you put when will this be 0? If you put 0 into the x, you will have minus e to the power of minus 0. That's the same as 0 here. And then you got plus e to the power. If you put 0, well, basically, if you put x equals 0 into that thing, you will have this thing plus this thing here. That does indeed equals, well, e to the power of 0 here is 1. This is 1 here. So minus 1 plus 1 is 0. So you see this thing here. So our point of inflection is when x equals 0. Okay. So looking at our graph here, we know that the inflection point is at 0. And we happen to know the intercept is 0. So the point of inflection will be at 0, a half. Okay. So that's our point of inflection. Now consider the range. The intervals. So let's consider when x is in the negative realm here. So hang on. Looking at this here, yeah. So we know the inflection point is right here. So now we need to consider the intervals from here to here, and then from here to over here. Okay. Will this concave up or will it concave down in this region here? In this region here. And then we will need to consider f double prime in this region. We've got to consider f double prime in this region. So let's consider in the negative region first. So let's look at this thing here. Hang on. So this is our f double prime here. When you hang on. When you bear with me. So we are trying to consider what happens we are trying to consider f double prime in the negative region. Now, if you look at this graph here, it looks like this. Okay, now if you look at this graph here, it looks like this. Okay, just bear in mind that when you have e to the power of x, it looks like this. E to the power of 2x is a lot steeper. Bear that in mind. Okay, hang on. E to the power of x looks like this. E to the power of 2x would be a lot steeper. Bear that in mind. Okay, so this this is e to the power of 2x. Let's say at a here, e to the power of 2x is a lot less than a to the power. Sorry, e to the power of 2x is a lot less than e to the power of x at a here. So notice there's a big gap in between the two. Just bear that in mind. Okay. Well, anyway, we need to consider f double prime in this region here. Well, in that region here, don't do this. This will be the wrong thing here, because don't consider. Well, in this region here, you've got to look at this as a bubble here. Don't do this here. So you might argue that when x is less than 0 here, this thing here will be negative. When x is less than 0, this thing here will be positive. And then you might think that this thing here will be a negative, because positive. But in fact, it's wrong. The reason why it's wrong is because when you have a negative here plus a positive here, you cannot deduce anything, because you cannot say that this thing here is negative, because, for example, you could have a negative 10 here plus a positive number plus a positive, let's say a positive 3 here. Then this whole thing here could be will be a negative. Or you could have a scenario where this is negative 10 and then you plus a positive number. But if you have a big positive number, let's say 97 here, then overall this is a positive. So you can't really deduce anything with this statement here. Okay, because you can't really deduce anything with this statement here. And then so you've got to consider it collectively as a whole here. Okay, so when x is, well, this bubble here when x is less than 0, this bubble here will become a positive. Okay, you probably have to press a video and really think for yourself here why this is a positive. But this here is a positive, and this here will also be a positive. Okay, so overall collectively, this thing here will be a positive. Okay, you probably have to pause the video and really think for yourself here, because it's taking me too long to explain this. So this thing here will be positive in this region. F double prime will be positive, and as it turns out, f double prime when x is above 0 will be negative, meaning that this thing here will concave up. Okay, and then over here this thing here will concave down. Okay, so meaning that it will concave up here, and then here it will concave down. Okay, so you probably have to pause the video and really think for yourself why f double prime here is positive here, and why f double prime is negative here. Think for yourself here, because it's taking too long here. Okay.